Creeping thistles, expanding in patches by creeping roots, are one of the most troublesome perennial weeds in the temperate regions of the world. The weediness and persistence of creeping thistles mainly depend on their vegetative growth and creeping root system. Creeping thistles have a vertically expanded root system reaching 3 meters into the soil, whereas creeping roots spread horizontally at a rate of 1 to 2 meters per year. Thistles, reducing yields in both annual and forage crops, significantly require controlling. Currently, environmental and social concerns, however, demand a reduction of ploughing in organic farming and the replacing of glyphosate use in conventional farming. Understanding the life cycle, growth pattern, and resource allocation of the creeping thistle is crucial in order to implement effective control measures, since thistles sprout and spread from creeping organs. The main creeping roots run horizontally in the soil. Their main task is to store resources whilst being organs of vegetative reproduction. Due to its extensive and fast-growing root system, thistles compete successfully with other plant species in extracting water and nutrients. There are 3 scenarios for the reproduction of these thistles, ranked according to their importance. The visible above-ground plant gets started after the emerging of the shoots. First, plants grow from creeping root fragments. Plants germinating in spring or early summer may produce aerial shoots 20 to 25 centimeters high during the first season. Below-ground shoot parts, cut at the post-bloom stage, produce new shoots and creeping roots at the nodes. The generative reproduction of seeds increases the ability both to spread to new areas and to an increase further into the already existing infestation. Being dioecious, male and female flowers can grow on separate plants. Sufficient and frequent control measures by farmers, especially stubble cultivation, can successfully limit the establishment of seedlings. 2 principal agroecological processes are used to manage creeping perennial weeds non-chemically: the increase of periods with competition and the disturbance of the system. Disturbance by ploughing suppresses thistles' creeping organ reproductive capacity and patch growth. Instead of ploughing, the same effects can be achieved with minimal soil disturbance by cutting roots and defoliating the above-ground parts. Shaded plants produce fewer shoots than unshaded plants, as thistles are very sensitive to light competition. Subsidiary crops, growing in the same period between 2 main crops, enhance light competition. Perennial legumes, or grasses, are the most reliable measure to ensure thistles face competition. Competition for light, nutrients, and water reduces thistle infestation on organic fields. Thistles additionally suffer from frequent mowing. A synergistic effect on creeping thistles can potentially be achieved via the combination of both root disturbance and competition from the subsidiary crop. This thistle root growth animation has been developed by researchers from the AC/DC Weeds project. AC/DC Weeds is a European project funded by Scop Eranet.